Hey, so let's talk about the sine rule. So the sine rule states that in any general triangle, so now this one is not a right triangle. This is just in general any triangle. The side A over the sine of angle A equals side B over the sine of angle sine B over side C of sine of angle C. So here's just a general triangle. This is A, B, and C. Notice across from it is A, across from B is B, and across from C, it should be C over here, but we put an H. I don't really know why I did that. But anyway, okay, here's how the sine rule works. And this is when it's useful. Let me find, oh, I thought I had a, I was looking for a highlighter. Okay, let me pause and find one real quick. Okay, I found one. All right, so the sine rule is useful in two circumstances. When you have two angles, and I made that bold, and one of the sides opposite. So two angles and one of the sides. Okay, you can use the sine rule to find the opposite side. When you have two sides and one angle opposite one of these sides, you can use the sine rule to find the opposite. So you'll get to where you kind of can just look at it and you'll be like, oh, I'm going to use the sine rule. And I love to use the sine one because it's just easier to use, but it doesn't always work the way you want it to work. All right, so let's take this first one and let's look at it. Okay, so in triangle ABC, right here, shown above, actually it's below, sorry about that, find the value of B. So you want to know B right here. So whenever you're given two angles, always kind of be like, could I use the sine rule? Opposite of 30, I have 7, and opposite of 70, I have B. So this will work. So I would say 7 over sine of 30 equals, and I would do B, because I don't know B, over the sine of 70. Okay, so you're doing the opposites, which makes it a little easier to kind of think about. Okay, I need to solve this for B. So the way I look at it is if I cross multiply, but I'm going to leave this here. So I'm going to take this. If I were to multiply both sides by sine of 70 degrees, it's really just kind of like multiplying. Sine of 70 times sine of 70. These would cancel out, and it would just leave me with a B over here equals sine of 70 times 7, or 7 times sine of 70, over sine of 30. And then I'm going to use my calculator to find that. Remember, be sure, we're starting another video, so be sure that you are in degrees and you're not in radians. Oh, that is super blurry. There we go. All right, so alpha y equals, I'm going to do 7 times the sine of 70, and then sine of 30 on the bottom. All right, so I got 13.1556. I'm going to do 3 sig figs, 13.2. So B is approximately 13.2. And I didn't have units on here, so I'm just going to leave it, 13.2. All right. Example number 7. Okay, I'm going to pull this up so I can see it there without having to. All right, so in triangle DEF, DF is 7, DE is 6. Find the angle F if the angle DEF is 124. Okay, so I've already kind of labeled here what you've got. I think drawing it sometimes is the hardest part. Remember to look across, so I could do 7 over 124. It wants to find the angle F, which is right here, and across from F, I have that side. So when you have those opposites, it's like, oh, I can use the sine rule. So I could say 6, right here would be opposite angle F, right? So I would say sine of F would equal, and it doesn't matter which way we go, but we're going to do it this way, 7 over sine of 124. Now, one more time. If you already understand that, solve this for sine f, if you would. Remember, you're going to look opposite the angles, and those are the ones that are going to be across from each other. That's how I set this up. All right. When I solve this, I'm going to put sine of f. Think of it like cross multiplying. And I'm going to go ahead and cross multiply on this one just for the math so that it's a little easier. I would have 6 times the sine of 124 when I cross multiply, butterfly, if you will. And I'm going to do sine f times 7 equals 7 times the sine of f. To get the 7 away from sine of f, I'm going to divide both sides by 7. Those will cancel out. 6 times the sine of 124 divided by 7 equals the sine of f. Okay, so let's do that. Let's do alpha y equals, and let's do 6 times the sine of 124 over 7. All right, so I'm going to write that whole number down. I don't want to skimp out on that. I'm going to write that whole number. 0.71060363336 equals the sine of f. Now remember, in order to figure out what degree has that, you have to do the inverse sine. So we are going to do the inverse sine of all of this. So I'm just going to put 0.7106 like that equals, and that's going to be the measure of angle f. But what I'm going to do in my calculator, I'm going to say second sine, and that puts the inverse. I'm going to use my mouse pad, and I'm going to go up so that it highlights that in blue, and I'm going to hit enter so it copies it down, put parentheses around it, and then I'm going to hit enter. So it's 45.28 degrees. Oh, I forgot to turn my page. I want to make sure my answer key's right. Yeah, that's what I got on mine when I did it too. All right, so hopefully you can see that. So that means the measure of angle F is approximately 45 points, and I'm going to say 3 degrees. All right, so that's how the sine rule works. You're looking at these opposite sides. So now we have the cosine rule. So let's take a look at the cosine rule. Cosine rule, you can already see if you're looking at it like, oh my goodness, that's a whole lot different. The cosine rule states that in any general triangle, again, these are not right triangles. These are just a general triangle, which means they're going to work for everything. The cosine rule is useful in 2 circumstances. You know one angle and 2 adjacent sides. See the first triangle below, which is this one right here. You know, or actually it's the one we're about to do. Or you know all the sides, and this is where I always think of cosine rule, and I know all the sides. The second triangle below, that's how you can find the angles, when you know all the sides. Okay, so here we go. So I'm going to move this up. So example number 8. In triangle ABC, CB is 5 centimeters. So here's CB. AB is 6 centimeters. I've got that labeled. And angle B is 37. So you're like, okay, find the length of AC. And you're like, well, could I use the sine rule? Well, let's see. I could do A over sine of 37. But I don't know this angle. I know 5 would be over it. Could I go the other? Oh, I don't know this angle. So when you don't know 2 angles, you can't use the sine rule. It just won't work. All right, so let's write down that cosine rule. Cosine rule says C squared equals A squared plus B squared minus 2AB cosine of C. You will memorize that. I promise you. You know, write it so much that it just kind of ends up flowing. All right, so C squared. So here we go. C squared. Where am I going? Okay, hold on. Lost my train of thought. Okay, so on this one, I'm using my formula, but what throws you off on this one, what was just kind of puzzling me, is when I look at this, like I'm thinking, okay, so this is C squared. this is the general rule. The side over here that I'm trying to find, think of it like this. This is the side that you know, and the angle. And I'm trying to make these different. I'm trying to find the A over here. So it's kind of like side, angle, side. They need to be attached to this angle to be the A and the B squared. So if I were to rewrite this one, I'm going to use this as my model. I want to know A. So I'm going to say A squared equals, and I'm going to take 6, and I'm going to square it, plus the other side squared minus, and then I need to take these two sides, again, because the angle's in the middle of them, I'm using that. So that'll be 6 times 5 times the, almost right sign, cosine of 37. And the thing I want you to notice is that these right here are all touching. Do I have my... That's kind of the big part there, and then this is my angle. All right, so you can see how they're touching. Everything's touching. So here we go. So A squared is going to equal 36 plus 25 minus 30 times the cosine of 37. I'm going to get my calculator out, and I'm going to just type that in. Okay, so I'm going to do 36 plus 25 minus 30 cosine 37. Oh, you know what I forgot? Oh, I almost forgot it. On my formula, there's a 2 right there. I forgot to put my 2 right here. So I'm going to squeeze a 2 in. 2 times 30 would actually make that 60. I caught that right as I was about to hit enter. Oh, there it is. I'm going to change my 3 right here to a 6. Okay, 2 times 30 is 60. So I'm going to go back over here. I'm going to change that to a 6. All right, there we go. All right, so I got that A squared is 13 point, and I'm not going to shorten this, 0.818694. To solve this, I'm going to take the square root of both sides. Second square root, I'm going to use my cursor, go up and hit enter. It copies it down, hit enter again. So A is about 3.6168867. 3 sig figs will be 3.62, and it was centimeters. Yep, that's the same answer I got there. All right, now that was the law of cosine, solving this, and in this situation we didn't know this one over here. I'm going to give you something to kind of like some math that's already been solved, that when I was doing all the homeworks and just in general, it was super handy to know. It was just kind of a shortcut. It is the cosine rule of angles. Cosine rule of angles. I think my blue pen has seen its better days. Let me chunk that one. I'm sad to throw it away. I love that pen. Blue's my favorite. All right, so here it is. If you need to know angle A, okay, it is B squared, side B squared, plus side C squared, minus whatever side you've got, minus that side, all divided by 2BC. Okay, so whatever angle you're trying to find, it's this right here. If I'm trying to find angle B, now let's see if we can follow that. So angle B, that means I'm going to be subtracting angle B because it's the one I don't know. I'm going to have A squared and C squared. So A squared plus C squared. Because I'm trying to find B, I'm going to subtract off B squared. And then down here, instead of 2BC, it'll be 2AC. All right, so now C, oh, I should have left myself more room. Angle C, let's see if we can put that here. So if I'm trying to find angle C, that means I would know A and B. I would subtract off angle C. And down here, I would have 2 times AB. This is just something handy dandy to know. I would highlight it, whatever you want to do there. It is very handy to know this on your law of cosines. All right. Some more of law of cosine and sine. So we're on example number 9. All right, example number 9. For a triangle ABC, AB is 5 centimeters, AC is 6 centimeters, and angle B is 86. Find the length of BC. So I've already drawn it out over here. I'm going to give you a minute. I'm looking at what I know. I always kind of think about law of sines, and I think, okay, I got opposite. I'm trying to find the side BC, though, and I don't know the angle. So I've got 2 sides and an angle. So what could I do to figure this one out? Well, I'm going to write down that law of cosine. C squared equals A squared plus B squared minus 2AB cosine of C. I want to know side BC. Okay, so I want to know this side over here. But I don't know this angle. So remember, when we work it, it's got to be connected. I'm going to kind of draw this in. It's got to be this to this. Here's the angle, and this is what you're trying to find. That's your opposite side there. That's your C squared there. So I've got the information I need, only it's going to plug in here a little different. So the side opposite the angle, the C squared, is going to be 6. So I'm going to have 6 squared equals, I don't know this one, so I'll call that one, since it's A already, I'm going to call it A squared. This would be the B squared minus 2 times A times C, which is 5, times the cosine of 86. Now, remember, C is always the side opposite. It's this longer side over here. And then you've got where it's connected, side angle side, is how we're going to work that. So let's see if we can solve this. 6 squared equals A squared plus 25. 2 times 5 will be 10. So minus 10A cosine of 86. Okay. I'm going to simplify that a little bit. This is going to get a little bit messy. So I'm going to say, let's go ahead and make that 36 right here. And let's subtract it. So it's going to look like this. I'm going to say, this is 36. I'm going to subtract 36 from both sides, so it's going to go right here. Okay. 36 minus 36 gives me 0 equals, I still have A squared. 25 minus 36 is negative 11. And let's simplify this. Cosine of 86 times 10. So let's do cosine of 86, and then we'll say times 10. So there it is. So this is, let's see, it was minus 10 times that, so this is going to actually be a negative. Minus, I'm going to write out this, 0.69756, and we still have that A right there. All right, so this right here was just a whole lot of algebra I did. I'm going to rearrange this. 0 equals A squared minus 0.69756A minus 11. Okay, and you're like, oh my gosh, how do you solve that? Well, that's why I wanted you guys to all have the red calculator. On the red calculator, we have a polynomial solver. This is a quadratic. Here's what we're going to do. We're going to hit the apps button. Apps is right here. We're going to go down to polynomial solver number 9. All right, so when this comes up, what do you want to do? We want to use a polynomial root finder. We want to figure out, what's the answer to this? If we were to factor this, what would we get? So we hit enter. What degree is our polynomial? This is the second degree. There's a 2. So we want the 2. All this down here we're just going to leave alone. And we're going to hit next. You hit graph and that goes to next. All right. We are going to put in what values we have. In front of x squared, we have the number 1. If there's nothing there, it's understood it's 1. So I'm going to hit 1, enter. And see how it put it there? And now it goes over to the plus sign. I'm just going to hit enter again. Instead of 12, I have a negative 0.69756. Negative 0.69756. Enter. And then on the end, I have a negative 11. I just always leave that a plus, and then I'll put in negative 11. You could put in minus 11 if you wanted. It doesn't matter to me. Okay, so now this, I need to hit enter because see, it still says 72 right there. I need to hit enter so that all my numbers are correct. What you do on this is you're about to factor this. So you hit solve. Here's your answers. You get x equals negative 2.986 and x equals 3.6836. I'm just going to put 36 right there. Now, we are looking at the side of a triangle. Which one of these is the most, I put x, didn't I? You should have put a. I'm just going to mark those off and put a, mark those off because we were finding a. The side of a triangle can't be negative. So the only option is this one right here. So that means that A equals 3 sig figs, 68. And it is centimeters. The side can't be negative, so we don't use the negative 2.986. All right, we are going to do plenty of these. So if you got a little bit lost in the polynomial solver, don't worry, we're about to do a whole lot more. All right. You can go back and watch that one again if you need to. All right, number 10. In triangle ABC, not to scale, find the size of the triangle ABC and give your answer correct to the nearest degree. All right, find the size of angle ABC. So this is A over here. It got chopped off. ABC. So they are wanting me to find that angle right there. All right, I don't know any of the angles at all. I only know the sides. If you only know the sides, you can use the law of cosine to help you out. So c squared equals a squared plus b squared minus 2ab cosine of c. All right, so take a second, see if you can plug those in, and then I'm going to show you how. And remember, this is the angle we want. So remember when we write it, this is how it's going to look. I'm going to highlight that so you know which way we're going. Remember the side over here is going to be my c squared. So 16 squared equals, and now I can use these, and these don't matter. 18 squared plus 22 squared. Oh, minus, I put equals. Minus 2 times 18 times 22 times the cosine of, and in this one, b. All right, so here we go. To get out of the polynomial finder, you got to hit second quit twice. All right, so 16 squared, I should know my squares better than I do. 256 equals 18 squared plus 22 squared. I'm just going to go ahead and do those together. 808. And then I'm going to do 2 times 18 times 22. So that will be minus 792 cosine of b. And remember, we're solving for cosine of b. So I'm going to subtract 808 from both sides. So 256 minus 808, negative 552. equals negative 792 cosine of b. I'm going to divide right here. Negative 792 on both sides. Negative 792. So, divide by negative 792. Okay, I got a crazy answer here. 0.696, looks like it just repeats. Cosine of b. Now, when I have a value and I want to find what the angle measure is, I want to know what the measure of angle b is. Remember, we have to say the inverse cosine of that right there. So 0.6969, that means that the angle, so I'm going to say second cosine, that puts the inverse. I'm going to copy that down here, and I'm going to say enter. And there it is, 45.8156. 3 sig figs would be 45.8 degrees. And there it is. All right, so here is a flow chart that I found on the web that I thought was, you know, it's kind of helpful when you're working with it. You can kind of keep it in your mind and keep it in your notes. All right, the first thing it says is it a right triangle? If it is, then you can either use Pythagorean's theorem or your trig ratio, SOA COT-TOA. That's where you're going to go. If it's a right triangle, so if we've got a right triangle, we're going to go this way, and we're going to come down, and we're going to see what we can figure out, okay? Now, if it's just a right triangle, or just a triangle, it's not a right triangle, then we're going to go no. So that might be something like this right here. It's some weird triangle. Can we draw a right triangle and make it work? Or yes, and if we can make a right triangle out of it, then bam, we're back over here, trig ratios all the way. But if we can't, then we need to either do our law of sine or our law of cosine, whichever one happens to work out. I tend to always gravitate to the law of sines, but as I look opposite of angles and sides, if it doesn't work out, then I just kind of have to roll with it and see which one might work. Okay, so here we go. We are on number 11. So take a second and look at that one. Triangle ABC has side lengths of BC is 7 and AB is 12. If tangent of A is 57, actually that's 5 over 7, y'all, sorry. Oh, I did correct it on there. Of 5 over 7, find the area of the triangle ABC. So I want to know the area of this triangle. It's not a right triangle, so I can't use my area equals AB sine of whatever it was. AB sine of C or whatever that, I can't remember what that one was. But anyway, I'm going to have to see what I can do. So first thing I want to do is it's not a right triangle, but could I draw a right triangle? And the answer is absolutely I can. All right, so let's see. The measure of angle, triangle ABC has side length BC 7, got that. AB is 12, got that. Now, where this comes down, I don't know the distance here on each side, so I do have to kind of think about that a minute. But I do know that tangent of A is 5 over 7. Well, if I drew a right triangle and tangent of this angle is 5 over 7, tangent is opposite over adjacent, I know this. If this side right here is 7, I kind of know that this side over here would be 5, I think, but I'm going to have to do a little bit of work. I can't just say that it's 5. So, because here's what I know. This is where this problem, like when I first did it the first time, was like, what? Okay, so tangent of A is 5 over 7. All right. I know that it's not a right triangle, right? And I know that area equals 1/2 base times height, which is what I want to use here to try and, figure out what's going on. So as I set this up, I know that tangent of A reduced to 5/7, but I don't really know if it reduced to that, what was it before that? So the way I thought of this was, I'm going to say that this height is 5 times some number. I don't know what that number was. And that would mean that 7 was that same number. And when you put 5x over 7x, those cancel out, and I'm left with 5/7. But I don't know what the original number was. So I look at this as 5x over 7x, which means this over here, you're thinking, oh, but this is 5. Well, it's really 12 minus 7, and whatever this reduced by to get this. And you're thinking, well, why do we even have to do that? Because it's all going to cancel out. It is, but it's not. You'll see as we go. All right, so this 12 minus 7x is this distance right here. And this one right here is 7x right there. All right, so here we go. I know that I guess what do we want to call that? Right? Let's put an H right there. We'll call this point H. It's kind of, or I guess I could have called it M. So I know that CH is 5x, and I know that AH, this distance right here, is 7x, right? And when I do tangent of A, those cancel out and I get 5/7. I'm perfect there. It all worked out. I know that area is 1/2 base times height of this triangle, right? So I can say that the area is 1/2 the base, which is, I got to be kind of careful with this. The base is 12 times the height, which is 5x. All right. So the area is 5 times 6. Half of that would be 30x. And they wanted me to find the whole area. So I can't quite use that just yet. So maybe I need to do a little bit more work, and maybe I could figure out this side right here. But I don't know that that would really help me. But how can I figure out what x is? What do I know that would help me figure out the area? Because I need a number value. I don't want x. So here's what I can do. Okay, this one over here, what if I look at this one? I know the side, and the side. Ooh, okay. Don't I know that a squared plus b squared equals c squared? And the only missing variable here is x. Over on this side, I don't know this other side over here. I guess I could do some work and figure it out. But this one, I already have all three sides. So let's see if we can figure out what x is just by using this side. So I'm going to kind of cover this up, and I'm going to say a squared plus b squared equals c squared. Okay, I'm going to say 5x squared plus, and this side right here, remember this is 12 minus 7x. 12 minus 7x squared equals the hypotenuse, which is 7 squared. Now, this right here is definitely some pre-cal type problems here that we are doing. 5 squared is going to be 25x squared. Now, when you multiply this out, that's going to be a whole lot of math. So I'm going to come over here and I'm going to say 12 minus 7x times 12 minus 7x. 12 times 12, 12 times negative 7, and we're going to go the other way. So here we go. I'm going to let you work it. Okay, so I multiplied here, and I multiplied here. Now I'm going to go under and do the other one. I have always stacked mine up when I work these. So that's 144 minus 168 x plus 49x squared. Okay, so all of this right here, this is a plus, so plus 144 minus 168x plus 49x squared equals 49. All right, I need to have it equals 0 so I can do that polynomial solver. So I'm going to put 25x squared and 49x squared. I'm going to get my calculator to make sure I don't mess that up. So I'm going to have, let's clear that out. Okay, 25 plus 49 is 74. That's this right here and this right here. 74x squared. Now I've got 168x and there's no other x's, so I'm going to say minus 168x. On this next part though, I'm going to move this 49. I'm going to subtract it right here. So I'm going to say 144 minus 49 is a positive 95. And it equals, these cancel out, and so it equals 0. Now remember, we're trying to figure out what is x. If we could figure out x, we would be good. So I've got a polynomial equation here. I'm going to go to apps. I'm going to go to number 9. I'm going to hit enter. I want to find the polynomial. It's a square, so I'm going to do degree 2. I'm going to go to next. I'm going to put in 74, enter, enter, negative 168, enter, enter, positive 95, enter, enter. Okay, 74, negative 168, 95. 74, negative 168, 95. I'm going to hit solve. My two answer choices are x equals 1.066 and x equals 1.2. Oh, that's messy. Let me fix that. Negative, or 1.20404. Okay, so I've got my two answers. And it says, oh, sorry. So you're like, wait, which one is it? Well, it could be either one. We're going to have two answers. So I'm going to do a situation where x equals 1.066. I'm going to put an or, and I'm going to say x equals 1.20. I'm going to say 4. Okay, I'm going to do this first one. I'm going to take this right here because I know the answer, right? So I'm just going to plug that in. So it's, depending on how you want to do it, I mean, it's going to be the same. So area equals 30 times 1.066. So, second quit, got to do it twice. 30 times 1.066. is 31.98, and it would be centimeters squared. And now we're going to do the other one, which is the area equals 30 times 1.204. So the area equals 30 times 1.2, what was it? 04. Oh, I hit an error. Okay, 30 times 1.204. 36.12. And you know what? I should have done 3 sig figs. So if I was actually doing this on a test, I would do 32.0 centimeters squared or 36.1 centimeters squared. All right. Was that one hard? Yes, that is what we call a level 5 problem. If you were on Cognitive and you were working those, I think that one actually might be one of your homework ones, and I wanted to be sure you guys knew how to do it. All right, example 12, quadrilateral ABCD has side lengths AB4, AD. Anyway, there it is, all right there. So it wants us to find the area of this whole quadrilateral. So here's what I thought when I wrote this one out and I drew it. I was like, basically I have two triangles, and if I could find the area of this triangle and just add it to the area of the other triangle. When I have triangles that are not right triangles, how do I find the area of them? Well, I know that the area is 1/2 A times B times the sine of C. Okay, that's one of the ways I know the area. And so I guess I just need to figure out what do I know? Can I do this yet? So I know, I'm going to look at just this one. I know this side and I know this side and I know this angle, but I don't know this one. If I have an angle, or I'm sorry, a side and an angle, can I figure this out? Well, the angle opposite this is right here and I don't know it. I do know this angle would help me here, but I don't know, like this angle, I don't know that either. So I'm probably going to have to use the cosine rule because neither side is going to get me where I need to go. I need to know BD in order to figure this out. So let's do our law of cosine. So c squared equals a squared plus b squared minus 2ab and cosine of c. So I'm just going to look at this one right here, okay? I want to find something to kind of cover this up because it confuses me when I can see all that mess. Okay, that's better. Okay, so across from the A right here, I'm just going to call that A. I'm going to kind of ignore this because I know it's just easier for me when I just highlight it this way. And I know I'm going to do this angle. Highlighters are wonderful. All right, so here we go. So I know that a squared is going to equal 4 squared plus 3 squared minus 2 times 4 times 3 and the cosine of 56. And that's going to give me this, and that's what I need in order to do this. All right, so a squared equals, I'm going to do a lot of math here on my calculator. So I'm going to do 16 plus 9. I guess I could have just done that in my head. 25 minus 12 times 2 will be 24 cosine of 56. This is just a number value, so I'm going to do that all together. 25 minus 24 cosine 56. And I got 11.579. So a squared equals 11.57937. Take the square root of that number. So A is about 3.402847. I'm just going to leave it there. Okay, so now I know what that length is right there. So to find the area, right, we're going to do 1/2 of, we're going to look at this one. We'll do 4 times 3 times the sine of 56. That'll give us this right here. So this side right here. So area equals 1/2 A times B times the sine of 56. And you're like, wait, well then why do we find A right there? Well, we're going to need it for the other side. So the area of this triangle here is, I'm going to do 0.5, y'all, times 12, times the sine. Be sure you push sine, not cosine, of 56. So I got 4.97422. So 4.97422. Okay, I know that one. Now I need to do this one, and this is why I had to do A. So now I know A, B, and I know the sine right here. All right, so here we go on the other side. So I'll do it over here. So the area of this one over here is 1/2 A times B times the sine of C. So the area of this one is 1/2 of, we found the A right here to be 3.402. I'm just going to do that. Times the B, which is 3. And we need sine of 63. So area equals, if you plug all this in, we're going to do it all at once. 0.5 times, I'm going to go up here where I had that number. I'm going to enter. So now it's multiplying by that. Times 3 times the sine of 63. Make sure I did that right. Yep. 4.4 5, 4, 7, 9, 3, 8, or the area is 4.55. I would probably keep this one right here to add it together. All right, so now I know, oh my goodness, the area of this one and the area of this one. I'm going to add those two together. So I'm going to put a little thing around this one. And I'm going to go ahead and put it around this one because I feel like I should do that to be a little more accurate. I'm going to go on my calculator. I need the second one plus this one equals, I got, the total is 9.522. So the total is 9.52. And it was centimeters, and we're doing the area, so it's centimeters squared. All right, so that one was a tough one. Like, you had to do a lot of work on that. I'm going to leave that right there for y'all to see. I hope that helps. All right, where are we at? Is it time to stop yet? Oh, my goodness, I am at 46 minutes, y'all, or roughly there. I think my timer may be off. But, okay, I'm going to keep going. If you've got this down, try that. I think this next one is a little bit shorter. So, anyway, there's a lot of them on here. I don't know how we're going to get through this in class. Whew! This is already over an hour, or the other video too. Okay, anyway. Example 13. The following diagram shows the quadrilateral ABCD, and we've got, given that AD is 4 centimeters, DC is 6 centimeters, angle BDA is 46. Okay, I have 52 on here. I'll have to look and make sure I didn't have a typo there. DBC is 71 and angle BDC is 34. Oh, I got a whole bunch of typos. Find the length of AB to the nearest millimeter. Do not give units to your answer. Okay, I'm going to make sure my picture is right. Oh, you know what? That's a different problem. That's why. I'm like, what? Oh, here it is. Okay, I found it. Sorry. My paper was different. Okay, which rule would you use? Okay, we're not actually solving this. It's which rule would you use? Okay, so we've got all this information. We want to know the following diagram, the length of BD. So let's look at BD. So we want to know, I'm going to highlight it. I want to know this length right here. So I'm going to give you a second to kind of look at that. What do you think you would use to find the length of BD? Which rule? Okay, anytime I have angles especially, I always look. So this would be the side. I know the angle. So let's say I call that x. If I said x over the sine of 58, just because I love the sine rule, and look, this angle 98, I know that 8 right there. It would equal 8 over the sine of 98. Bam, cross multiply. Didn't have to know squares or nothing. So I would use the sine rule for which triangle? BCD. The sine rule for triangle ABD. ABD. Did I use this triangle over here? No. I don't know these angles right here. I don't know those. I can only use this one over here. So I would use this sine rule. I hope you got that. All right, 14, the following diagram, this is the one I was reading a while ago. The following diagram shows quadrilateral ABCD. All right, given all this information here, find the length of AB to the nearest millimeter. Now, on this one, it's kind of like this one up here above that we did, only we don't know, like it's not a question like what we just had. It's one where you got to actually work it. So, I'm going to give you a second. I'm going to encourage you to pause your video and work it, and then just fast forward to where I do the answers and see if you got it right. All right, so the following diagram. So here we go. Find the length of AB. So I'm trying to find this length right here to the nearest millimeter. One thing I do notice on this one, I could actually, I'm just going to like put in some information that I know. I could figure out this angle right here, right? Because they have to add up to 180, right? So 71 plus 34, and I could take 180 minus that and see what I get. And when I do, I end up getting, I believe, 75. I think it's 180 minus, oh, I should put that like that, guys, because I'm going to add those two together and subtract. So that's 105. So I'm going to get 75. So that's a 75-degree angle there. Now, I don't know if I'm going to need that, but at least I could get that done. Wait, if I know 3 angles, and I know this right here, I'll call that x, I could do the sine. I could figure out x right here, right? And I'm trying to find the length of AB. So I'm trying to find this right here. I don't know enough on this triangle, but if I could find this right here, couldn't I do the law of cosine? And I could figure that out right there. So let's see if we can figure out x. All right, so I'm going to say 6 over sine of 71 equals x over sine of 75. I'm going to set this up, and so I'm going to end up with 6 times sine of 75 over sine of 71 equals x. All right, so let me solve this. Lots of stuff. Alpha y equals 6 sine of 75 over sine of 71 is 6.129. So I'm going to say that x is approximately 6.129. I'm going to go ahead and throw some more numbers on there just so I have them. All right, so now I know x. Well, the law of cosine. If I'm going to call this one over here, let's call this, we'll call it D because it's opposite angle D. If I want to know D, I would say that D squared equals these two angles, so 4 squared plus this all down here, 6.12948 squared, minus 2 times 4 squared, or just times 4, times that whole mix. I should have just used x right there. 6.129498 cosine of 52. I'm hoping that little annotation isn't showing up on y'all's video. Okay, so here we go. D squared equals. I'm going to do all of this on my calculator. That's just one big old number. Okay, so here's what I'm going to do. Move this over here to the side. I'm going to do 4 squared plus, I'm going to go up. That number right there, and I want to square it, minus 2 times 4 times that big number again times the cosine of 52. And that is not what I got. Oh, yeah, that is what I got. So that's 23.38118521. I got to take the square root. So second square root of that big old answer. All right, so D equals 4.8354. All right, so let's remember what we're trying to find. We just found this side here, D. But they asked us for the length of AB was what they wanted us to find. Find the length of AB to the nearest millimeter. So that means they don't want a decimal. They want it to the nearest millimeter. Oh, yeah, nearest millimeter. Okay, so D is 4.8354 centimeters. We need to convert that over to millimeters. So that means it's going to be 48 millimeters. There we go. Bam. Remember, millimeter is smaller than a centimeter. So if it's smaller, you're going to have more of them to try and reach the other one. So you move this over once to make it a millimeter, and you round it to the nearest whole number, so it would be 48 millimeters. That's another level 5 problem. Okay, so that concludes the lesson part. Everything else is your cognitive homework. That goes with this cognitive number 6. And we're going to have that due, I believe, on the 29th. So you do have some time to work that.